Lamba means perpendicular vertical line in which angle the show is line. So this is the mark on which I will place my mirror like that. Okay? Okay, this is nothing. This is given for support actually. So if you have to draw one line also. I have to draw one line so that I can project a ray. Suppose along this line I will direct one ray. This is the line. Okay? So place the mirror just on the line. Clear? But where is the ray? Now you see it's laser. Okay? If I direct the laser along this line, what will happen? You see line, ray is going along the line. Can you see?
Yes, sir.
You can direct the ray anywhere, but as I have drawn a line, so I am just directing the line along this line. Okay? Now, the light is coming out. That is what? Reflected back. Reflected back. And if I draw two spots on this ray, what will happen? One line, one. Okay. And another ray. So ray was directed along this line. Okay. And it was reflected along this line. In which line it is reflected, I have taken two dots on the paper. So if I remove the dots now, I can get the trace of what? Of the ray to which light was going. You don't understand. Light is, you see light is reflected. Along this line, I have directed one ray and it is reflected along this line. So, to which line it is coming out? If you trace that path, because light will go off. On a certain day, light will go off. So, which line did the light go? How do you understand? Marking. So, I have given 2 marks. Without 2 marks, you cannot get a line. If you give 1 point, can you draw a line? No. So 1 point you can draw thousands of lines. But with 2 points, we get only 1 line. Right? If you want to draw a line to 1 point, you can draw thousands of lines. Why? This line. So at least to mark the ray, we have to draw these 2 dots. So I have to do 2 dots over there. Now you can replace. Remove the glass, and if you join this ray like that, you see the angle is almost same. This angle is equal to. If you measure this, okay, you get, I think, almost same. As this is a last experiment, so then you find a slight error that is there. But the angle will be quite same. Let us see angle is what? Angle to be angle is what? For measuring angle, the instrument what you use, do you know what is that called? It is what? It is what? It's called protractor. Protractor. Okay. But simply you say that protractor. Protractor means by which you can measure the angle. You can measure the angle. So what angle is there? You place the this is just fantastic. The angle is what you see? 10, 10, 10, 90 minus 61, 30 degree. Both 5, 35. So this angle is 35. 35 degree. Have you heard about degree? Angle is called degree. What is called degree? You take a circle and divide equally to center 360 part. Each part is called 1 degree.
The unit for the angle.
Okay? You draw a circle and divide it to center. How many parts? 360 parts. Okay, sometimes you say that look around 360. That means what? Look around you. It is called 360. So it is 360 and it is also 1, 2, 3, 30, 35. How fantastically it is matched. So I is equal to R. Reflection or main principle is what? Angle of incidence equal to angle of compensation.
Yeah, reflection.
Relatively.
You know, you have learned about this?
Yeah, quite 100% correct. But roughly I did the experiment. If you do it more carefully, it will be more nice result. But roughly, it's quite. We have got that I is equal to R. I means it is called angle of incidence. R means angle of reflection. So it is mirror, and in your book you see that law of reflection. There are 2 laws. Number 1, incident ray, reflected ray, and normal. Normal is what? Perpendicular to a medium in a plane. Perpendicular, that means which makes 90 degree the down or on a plane. Okay? So it is I is equal to R. That is the basic rule of reflection. Is it clear? So in reflection, first you know what is the reflection of light, not only light. For anything, sound also reflected. You know, sound also gets reflected from the surface. Reflection of sound is called what? It's called echo. Okay, sometimes in a theater hall or in a music hall, if you say hello, 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 coming from other side, that means what? Reflected. Sound reflected, light reflected, microwave reflected. In radar what do you do? One wave is sent from some source, antenna, and it will get reflected from some other source, and you can find the distance by the reflection of microwave. So now, reflection understood? So reflection is the bouncing of light from some reflection from obstacle, and in that case, I is equal to R. Angle of incidence, angle of reflection. At what angle there will be incident on the surface, at that angle will be reflected back. Clear? You are directly at 100 degree. You cannot expect that R will go to that wherever that. It will perfectly correct. Done. First, number 1. Number 2, this experiment we showed a few days before. So mirror purpose is done. So mirror is used for what? To get the reflection of light. Okay? You can see your face. How? Because light is reflected from, and if you produce the rays back, then the image is formed. This is the virtual image. There are 2 images formed by light. One is called virtual, one is called real. Virtual is what? You can see, but you cannot catch it. In a mirror, every day you can see your face before coming or after going from school. But real image is what? It is focused on projector or any camera, etc. Now you see reflection. 2 words. One is called reflection. R-E-F-L-E-C-T-I-O-N. Now we are showing refraction. R-E-F-R-A-C-A-T-I-O-N. So sounding and spelling, it cannot be wrong. Because if you make it wrong, then it means some other different thing. Okay. So refraction is that. Reflection is coming back. But reflection is called pass into. Light will go through some medium. Okay? Light will go through some medium. That is why it is called reflection. A reflection. So in this case, I think we get it from other side. I can turn the paper just opposite. Now you can see clearly what is that. Light is reflected. Okay. These pieces are also required for some other experiments. You don't think that this is rubbish, not that. It was important for us. Okay. So let us put on glass block over there. Okay. Now you see, and two perpendiculars are drawn. We do the boundary of the glass, and I have drawn one perpendicular there and one perpendicular. Now you see, just some of you, like, just press the light like that. Will do along this line. Just along this line. Just you press it. Yeah. Along this line. Yes, along this line. Just you focus this point. You see perfectly the light is going out along this line. Okay? Can you see? Light is coming out along this line. That means what? Light is incident on this point, get refracted to the glass, and again coming out. Again coming out along this line. You lift it a bit up. A bit up. Okay. You see how light is coming? We have drawn this line. And if you see through this, light will be reflected back. You can see that light is bending. Light is incident at that point, but you see it is coming out from that point. Why? Okay, fine. It is now clearly seen. And some light is reflected back. From smooth surface, light will be reflected and let's say like this. Now it's clear, very clear. Okay? So light is falling along this line and it gets burst. That is coming out along this line. Now pull it up. So you see light incident from P and it gets what? Just out from this RS. We do the line PQ and RS and join Q and R. What happened? If you see that QR is not the same, maintaining not same line. QR is not maintaining the same line. You see, the line is like that. If I draw the line, incident and reflected, it would go like that. It will go like that. But did it go like that? No. It has gone through this line. That means it is shifted. Why shifted? Because light gets refracted. That is, this is angle I, this is angle R. What is R? Angular refraction. But light reflection, it will not be same. Okay, in reflection I is equal to R. But in refraction, I is not equal to R. There is another relation. It is a bit complicated. and I think it is not done in your class. Okay, that means if you take side by side, quite different thing. It's trigonometry. We don't know. Trigonometry is different thing. You have to do maths, trigonometry, sine, cos, tan. In higher class you will do that. So I am not going to that this way. Okay, sine by sine, if you take a ratio, then it will be constant. That constant is called differential index. That differential index is constant for particular material. Okay, if the differential index is more, refraction will be more. And we have seen what kind of dust. There are much variety of dust. Ground, flint, there are different names also. And different names, they have different differential index. Okay, so you get satisfied with the light ray refraction. Because it is not in a skill, I don't know how far it is given in your book. Okay, but in class 8, surely you will get, and we will teach in physics. That's sine by sine constant. This glass, it has got constant 1.5. 1.5 means that is its refractive index is 1.5. If you get a glass where refractive index is 1.7, then light will be reflected more. Even a diamond. Diamond has much more refractive index because it is much harder, much thick, much strong. It has got 2.4. That means what? Light will be reflected much more than glass in diamond. And that is a diamond is so shiny. Okay. Done. So reflection we have done. Reflection through glass we have done. Then we are going to take one prism. What is called prism? A triangular block of rock. Very beautiful. Almost like diamond. Why? Because from different phase, light is getting reflected and refracted. So it appears to be very shiny. What is that? Same thing you can see that if you place the prism is like that, again you do some other boy, you take just you direct the ray through this line. Through this line, you can see the light and the body of the through this line. You go to that position. Right? You will get it. Along this line. I have just directly through this line, you see, the light is going on. Okay, you see? Light is going along that line. That means I have directly the light towards this line, but it is very reflected around this place. Why? 2 times light is reflected. One from red to glass, then from glass to red. 2 times light is going or getting reflected. If you direct one ray, it is going from red to glass. Then it is going from glass to red. So if you remove the glass, you see, once light was given from this side and it was coming out from this side. But one thing is that this is the reversibility of light. In which way light is going. If you direct the ray through that way, it comes in the same way. That is why in a bus or car, you see, there is a front view mirror in front of driver. Driver can see you through this mirror. if driver can see, we can see also travel through this window. Why? Because light is going from you, falling on the driver side. At the same time, light is coming from driver, it will fall on your eyes. So that is the reversibility of light. What way it is going, it will maintain the same way if you direct the ray from reverse direction. Okay? So light is going from this side, reflected once in prism, then again reflected from glass to air. One rule is that when light is reflected from air to glass, it will bend towards the normal. When glass to air, when air from the normal. That is why principle is this. This angle is small, this angle is bigger. Why? Because it is going from air to glass and it is going from glass to air. Okay? So you read about this thing in your book and try to understand. And if you have any question, next day, day after tomorrow, whatever, you write in your copy. Whether any question arises in your mind or not. No question arises in what? You didn't start. Okay? If no question arises in your mind, what does it prove? Then you did not think about this matter. But if you read, if you think about this matter, some question may arise in your mind, you may bring those questions next. Okay? If you are interested, then you can think about that. If you are not interested, what can you do?